Well, I'm going to assume I'm online. I'm just getting set up, actually. I'm doing... Good evening. Hello. The plan is to just do a quick live stream to have a look at this. Because this is my kid's Xbox 360. It was actually my Xbox 360 Slim. That's barely had any use, actually. Just to show you from above, here it is. Oh, I need to get that focus sorted out, don't I? Let's just sort that first. Are we in manual? No, we are not. Let's get into manual focus so we can actually see what we're doing. Ooh, no, that's terrible. Ooh, no, that's getting there. Ooh, that's better. Ooh, no, we'll go with that. There we go. It's my kid's Xbox 360. It was mine. It was my Slim. It replaced my original Xbox 360, that red ring of death. This has been in my kid's bedroom. We've been moving stuff around, and it's decided to do the flashing red light of death as well. So I want to take it apart and have a look at what the hell's going on to try and understand why. Hello, how are you doing? Just came in a British pub quiz in Sweden. Okay, that's a very random set of events. A British pub quiz in Sweden. I haven't got the comments. Have I got the comments up? Let me just have a look what I've done, because this was all very last minute. Let me just get this sorted out. To give me 2 seconds. Let me just pop out chat. Get that copied. Go back to OBS. Copy that, mess with that, do that, do that, do that, do that. There we go. We've got him up in the corner. Now I need something so I can see the comments myself, because I haven't actually got it up. So what do I need to do? I need to bring it up on my phone is what I need to do. So we're just going to quickly take it apart. I got no idea what's wrong with it. This is probably going to be a boring video. I'm not sure we're going to ever get to any board repair, but we're going to have a look. Now, as I said, this has been in my kid's bedroom. I'm on the wrong channel. Oh, there's a notification. I've got a notification that I'm live. There it is. Ooh, get down, get down, get down. Right, I'm your first thumbs up. Thank you, fella. How are you doing? I hope you are safe over there where you are. How is it over there? Ash, you know, obviously the rest of the world seems to be melting down right now. We've just seen Germany and a couple of others announce something's kicking off over there. But I hope you and your family are safe and well where you are. So anyway, Xbox 360, I've already partly disassembled it. I've got it to this point because it's a complete pig just to get it to there, to be honest. Getting the plastics off this thing's horrendous. It's been sitting on the shelf in my kid's bedroom for probably 2 years. It's hardly had any use, but it has been plugged in all that time. And it's decided to give up the ghost. I have a feeling we might have some capacitors that have expanded or something like that, because it has been on mains power all of that time. So that means juice has been entering the console. And unlike the original Xbox that had quite a multi-pin connector where the console controlled the power supply, this one is a bit different. So we're going to strip it down. We're going to have a look and see what's happening. Now, obviously, if there's any news, please do, or anything interesting, please do put it in the comments of the video. I'm just going to get myself some of the actual tools I need to do this. There's been enough leaks this week from DJI. I'm on the wireless mic as well today. I'm not using that one. I'm using the RROD, which is strapped onto me there, just so I can move around a little bit. But I can get the radio voice mic on if people want it as well. Now, I don't know how many people are actually even watching this. Oh, there's 3 of you there. Hello, 3 people. Hello, how are you doing? As unprepared for this as I am, I haven't even got all the tools I need in place. So let me just do that as well. What I should probably do is cheat and just steal the tub, which is my magical tub of random torques and screwdrivers. I got a proper bit set here as well if we need that. Also, it was my birthday last week. Someone bought me that. Look at that, Lord of the Rings Gollum mug. No comments, please. Yeah, but it's been an interesting week. We've had, it seems that the new Mavic is available to buy in the USA, officially or unofficially, we should add. To those who spotted my schoolboy error, it was Ash caught me out on, not caught me out. What happened with that is, I'll just explain that. Someone shared an image and it was very late. I'd had a very long day and I assumed wrongly that that was the image of the new aircraft. And I put a post on Twitter saying, oh, it's interesting, it's using the Mavic gimbal. I wasn't off my face on white powder at the time, as I might have suggested. But it was just me not paying attention. That was the reality. Now what we're going to do is we're just going to get the screws out the top of this a second. Let's put myself up in the corner as well. It was me not paying attention, but we do have it looks like there's a new Mavic Mini coming, Mavic Mini 2, or Mini 2 as it is, because DJI are in the process. Take it easy, Ash, you stay safe. DJI are in the process, where's the next black screw, of renaming most of their products. If you do have any comments or anything as I'm doing this, please do put them in the video. I'm assuming that is the 3 screws I need to remove to get this damn plate off. Nope, there's a 4th. One thing with these consoles is they're absolutely terrible to take apart. They really are. Anyway, is that? It's looking like it. This is literally... what's going on? Missed one over here as well. But yeah, it does look like DJI have sorry, can I get basically there's that new aircraft coming, and it makes a lot of sense. It really does. Hey, oh god, you don't open it that way, everything's falling out of it. Let's flip it over. There we go. So that's the cover. So it does look like we're going to end up with a Mavic Mini 2. What we're going to do is undo the drive. Now on all these things, if you've not seen inside, this is an Xbox 360. Again, it's got its DVD drive. It's using a serial ATA connector, interestingly, but it's got a custom power connector and comms. You can't use any normal drive on these. It is a specific one to Microsoft. We're going to pop it over there. Now I've removed the internal hard drive as well. Now we're just taking a bit of a closer look inside. What I'll actually do is zoom on in so you guys can see. I definitely need to get more light here. That is for certain. Let's focus this a bit better so you guys can see. So that will sort itself out. Now I need to turn off the focus thingy on it. So we've got that out. So we're going to continue to strip it down and try and have a look at where the power comes in. The power comes in over this side here. So the major power circuit is actually going to be over this side of the unit. So we need to keep digging to find our way to that. So we need to have a quick look at what else we need to take out. That comes out just like that. And then we've got the CPU fan and the heatsink, which we'll get to in a second. We've then got our chipset, which is down here. We've got our memory, which is our NAND flash over here. So yeah, let's keep stripping. There's a screw on the side there. I'm assuming that is for that. So let's pop him out and keep going. Now this is going to be one of 2 issues on this Xbox. It is either going to be a classic issue due to poor solder or lead-free solder and all of the common issues. There's a screw there on this holding that one, so we'll undo him. Or it's going to be something like an ESR issue on capacitors or an expanded top cap. I'm not sure what they're using and how much of the power stage is internal on this unit compared to, say, what we're used to in a switch mode power supply, for instance. So we're just going to undo that and get that out as well. And then we're getting to have a look over to the power side of the circuit. Okay, so what we've got is our input capacitors here. Let me just find something I can poke it with. So we've got our main power stage. So we've got our main power supply in over this side here. We've got then our 16 volt 470 UF caps. We then got some smaller caps down the bottom here. Now, because this has been plugged into power for the entire time that it's been sitting on the shelf, one of 2 things. Either we have had some of these caps dome up, but they do feel fairly flat. Now, these ones don't tend to, and what make are they? Doesn't say. Or it is a classic example of the solder issue that we get, but it's not had enough use really to warrant that. So let's keep going. What we're going to do is take the heatsink off. Let's get the heatsink off the CPU, which is those four here, as you can see here. So we will we'll get them off. We're going to need a different Torx bit for those ones. Let's. I'm not sure how many are watching. I haven't got this set up properly, so I can't see fully. But this isn't the best way to do this because the way I'm doing it is opposite. Now we might actually have to take the board out and the bottom cover out to get to this. I'm not exactly sure because interestingly these screws are not very long at all. So I think, yeah, that is very much, oh no, maybe not. I don't know, maybe. Let's have a look. That feels sprung loaded as we would expect. Yeah, we're gonna have to get the board out. Okay, so let's keep going. So let's get these additional harnesses off. So whether this is going to end up as an oven jobby, I'm not sure yet. Better get the module off the front as well. Now, this is the problem with lead-free solder. You get these strange issues on the balling of the BGAs. And you get, let me just take this one off to get the front board off out of the way. And it's frustrating because you've got a product here, right, that sat on the shelf doing nothing. And it's just decided to go, no, I'm done. I'm no longer playing ball. As far as I'm concerned, I'm broke and I'm not going to work for you anymore. We're just going to get these ones off. I'll head back. I haven't got it. 2 guys watching. Is it 2 people watching? It says 2 people watching. I think. Let me have a look. So what happens when I should have my actual settings up? It is a public stream as well, I'm assuming. Yeah, 2 or 3 guys. So whoever you are, say hello in the comments. I'm just going to continue to get the screws out and have a look. Now, initially, those caps look good, but really, it could still be an ESR issue. They're not domed, like I have seen some of them pop off, but it could, again, still be an input issue on the power stage. It's hard to know. I'm leaning at the moment, just having briefly looked inside, at an issue with, as a typical issue that we would expect to see. Let's get him out of the way as well. All right, how easy does this board want to come out? Here we go. We're going to get him out as well. I'm just going to zoom us out a tad so you guys can see. Now, you know, the reality is this is basically a mini PC. You know, that is the essence. It's an AMD-based mini PC for the most part. I think it was AMD they were using on the Xbox 360. I'm trying to remember. Obviously, this is an original unit. Just looking on the back of the board, looking for anything untoward, which we're not seeing at this time. Obviously, this is the CPU clip for the heatsink. We'll check that now in a second. I haven't actually brought the PSU up with me a minute. None of these here. These are the input caps. We've got the main input rail here. If we look underneath, we've got the voltage coming in. We've got ground. Then we've got our capacitors. Then obviously there's going to be some voltage changes down for the main unit as well. So far, nothing is looking out of place capacitor wise. Everything is looking as I would expect. However, that isn't to say that one of these isn't down or isn't playing up. So let's flip him over. Let's get the let's get this off. Now, these damn things are often quite a pain to get off. and it's very easy to actually damage something when doing these. There is a proper tool for doing it, which I obviously haven't got. So let me find what I have got a second. This one might not be small enough. All right, one. So what we're going to do is pop him there. Pop him there. If anyone watching, did you see the AMD launch today of the new GPUs? Be interested to know your guys' thoughts if you're into that sort of thing. The new 6000 series. Looking to compete with the NVIDIA 3000 series. Quite interesting indeed. I think the only problem is if you are, just going to get a smaller straight edge so I don't do any more damage than there already is. If you are considering, I think the biggest question at the moment is the compatibility on software. I think that remains to be seen. Oh, there we go. We'll hold that in place while we flip it over. And then we've got our heatsink. Ta-da! And that's our heatsink and our custom thing. And what you've then got is our RAM located around the sides and our main chip there. We need something to wipe that off. What have we got? Let me just get a cloth to wipe that down. Should be one here somewhere. Why does everything disappear when you want it? It's always the same, isn't it? Whenever you're doing anything, everything disappears from in front of you when you want it. There's a pair of little boy's trousers roaming around here somewhere that I have bought up from my boy because, they're here next to me. Blind as a bat. A pair of shorts from what was a 4-year-old, which is now a cloth for the workshop because he's no longer 4. And we recycled as many of the clothes as we can, but... Okay, so give that a nice clean off. Pop that around so you guys can see. That is the SoC in the Xbox. I'm trying to remember. No, these weren't ARM, but these weren't AMD based. This was PowerPC based. I'm forgetting where I'm at now. It was AMD based on the new Xbox. On the 360, it was based, if I remember, very much on... I'll have to look back because I could be wrong here, but I thought it was based on PowerPC because that's what they moved towards PowerPC architecture when Apple moved away from it. Just getting the rest of the chunks of heatsink compound off. So let's take a closer look into this board and see if we can see any issues, shall we? Let me also see if I can crop in a bit more for you guys as well, because with the magic of a GH5, we have our teleconverter option. When I come round to the side and find which button it actually is, I think it's the top one. So let me find the teleconverter. I can't see the display on the camera. Sorry, 1 second. That way. Let's go. Teleconverter. Perfect. Let's get you focused. Here we go. So let's have a look over this and see if we can see anything. So if we start in the top corner, this is our main power input up here. So we're just looking around. So we've got our caps. To me, these look fine. There's no doming on them. If I put a bit of 3D on them, we look fine there. No particular issues along there. If we then roll along and we've got our, in all essence, our VRM area and our voltage regulation area, which is where we do all the voltage regulation for the CPU. Obviously, there's a capacitor not located there. We can go down and look at all of them. They all look good to me with no problems at all. Again, if I do a 3D for you, no bulging, no nothing on those caps there. We've then also got a couple of smaller caps over by here, but again, I'm not refocusing for that, but they all look pretty good. So we're going to go along. We've got a little IC down here, not sure what that one does, but again, it's all fine. Moving along to the memory. We then got what looks to be another voltage regulation stage over here. We've also got our inductor, another capacitor. We then got another cap down here, but again, everything at this point looks good. No particular issues. Moving along, and then we've got our SoC, which is the XCGPU. But again, no issues particularly there with all of our little signal capacitors located around it to filter out the switching. And then as we move across, we've got more of our voltage regulation, our VRM circuit, and various other bits. It's interesting how much is missing off these boards. You know, if you look at how many components are not fitted on this board. Little IC here, another something here, something not here, not here. You know, all missing from the factory. I don't remember there being two versions of this machine. I could be wrong, but I don't recall. But other than what Microsoft haven't fitted at the factory, it all looks in good order. We then got another inductor here, again all part of the power circuit. Another capacitor here. Again, looks pretty good to me, no issues at all. And these ones are low voltage, you know, these are 2.5 volts, which is much lower than what we've got on the other section. Again, more areas with more capacitors not located. That's our, I think that's our, is that our infrared or is that a sensor? I think that's a sensor of some form. And then scrolling further down the board. Again, another capacitor, which looks good. So far, everything looking good. And then really towards the bottom of the board, where again, nothing looks particularly out of place. You know, everything looks exactly as we would expect it. Again, another area where lots of components are never installed from the factory down here again. And obviously we've got the Microsoft logo on the board there. And then if we flip it over, obviously there's still a lot more circuitry on the rear. Bit of dust on him here and there, but this board, you know, there's been no, this board's not been, you know, this Xbox not been water damaged or nothing like that. So, yeah. Not good. Not good at all. So, to me, this is very much looking like a solder issue, a traditional lead-free solder issue around the SoCs. That's what this is very much looking like at this moment in time. Now, just while I just have a look, Xbox Slim oven, because I don't know if you do know, people have been putting to solve problems, fixing RROD by motherboard into an oven on iFixit. I haven't got my laptop connected, so I can't show you. It isn't something that's recommended. However, it is something that has been done and has been proven time and time again to help repair them. Heat gun is another one. Reflow in an Xbox 360 motherboard, the iFixit guide. Pardon me. Reflow in the Xbox 360 motherboard. Introduction. Let's have a look. Let's bring this up on full. You need a high temperature output of a heat gun to accomplish the reflow. Well, I've got one of them. We might give this a go because we've got nothing to lose here. Tips to reconnect with their contacts. Motherboard to safeguard future failures. We strongly recommend installing our Red Ring Death Fix. Now, this is an Xbox 360 Slim, so there is a difference here. This isn't the standard. So Xbox 360 Slim flashing red light, which is the issue I'm having. It means that your console doesn't have enough ventilation. Well, it did. It doesn't even turn on. The issue is you hit the button. The second you hit the button, it flashes red. Power on, red flashes 11 times. Hardware failure. You need to send it in for repair. Well, we're not doing that out of warranty. Needs a reflow. So we're gonna have to give it a reflow. Okay, that's what we're gonna have to do. Let's go with that then, shall we? Let me just bring the comments back up on here if there is anyone there. Let me just put that up there. It looks like we're gonna have to go for a reflow on him. Xbox 360 Slim reflow. It's not something I've ever done, but we'll go for it. We will, iFixit. iFixit have got a guide. Let's just have a look at what iFixit are telling us. Let's do it. Let's bring it up. Let's bring it up. I'll put it on the screen for you guys now so you can see. 2 seconds. It's no good if you can't see it, is it? Xbox. Let me just bring up OBS. Okay, so you guys can hopefully see this now. So we've got a refixit guide, a fix-it guide on iFixit, which shows us how to do it. Let me just get my phone back in my hand and get YouTube back open so I can see what I'm doing. Let's have a look. So the refix guide's a heat gun, torque screwdrivers, yes. Well, this is the Xbox guide, but it's no different. It's the same thing. So what are they actually saying? I'd be interested to know. I've done reflowing before, but I'm intrigued to know what they're saying. I've actually got, we could actually use the hot air solder station. Yes. Get stripped. Come on, all the way down. Yes. We're at that stage. Yes, we've taken all of that off. So what they're saying is this: if replacing motherboard, transfer thermal paste. Okay, so that's the original chipset on the Xbox. Clean the old thermal paste off the CPU. Lay the board to processor side facing down. Interesting. And what they're saying is reball from the back. For 1 minute. Flip the mode over and lay on the chassis. So heat the back for 1 minute, heat set to high, evenly heat the areas in the floor. So what they're recommending is we heating the chipset, the RAM, the main chipset, the RAM, and the CPU. So this is what they are recommending. Okay. So the question is, do we use the hot air solder station, which probably, I'm not sure it's got enough go for this. If I'm honest, or do we use the actual heat gun? Okay, let's go for the reflow station, shall we? So let's fire him up. I think we'll take the nozzle off, is what we'll do. Let's go to full screen. So we've got it here. Let's take the nozzle off. So we're going to go with the full end. I'm going to have to bring it a little bit closer for this because we're a little bit far away. So let's get it starting to warm up. Now I'm on 448 degrees. Oh yes, as you can see, we are heating nicely. Let's just let it get some heat into it first of all. Now let's just have a look at where we're aiming for. So what we're going to do is we're going to aim first of all for the back of the main CPU area, which is here. So let's just get under the camera. So we're going to aim for this area here, just to put some heat in the board first of all. we're just going to do this. Just keep getting plenty of heat into the board. Just so when we start looking at actually reflowing on the other side. No guts, no glory. Hello, Robert. How are you doing? Welcome to the stream, mate. What you got to lose? Yeah, nothing at this stage, exactly. You know, she's dead, so let's get some heat in it and let's see what happens. And I'll head up and get the PSU in a minute. So it's frustrating, though, these issues, isn't it? On a product that, you know, it's not from use. It's barely been used, I'll be honest, because my original Xbox 360 failed and my kids were quite young and they'd started playing it. So I went out and bought the Slim. And I barely used it. Honestly, this probably hasn't done 50 hours. Honestly. And my kids haven't really been a big console players. They're only young. They've not really been big console. Just feeling how much heat I've got on the back of the board there. But they're getting a bit older now and they have said, Dad, can we start using it? And we've just been moving everything around. So I'm going to turn the board over. And the first thing we're going to do is we're going to go with the main chip. So what we're going to do is go and see if we can go with a reballing of the main CPU. And we'll go with a RAM at the same time. But they sort of said to me about, yeah, you know, can we start using it, Dad? And I was like, okay. And then found it was doing this crap. You know, if I wanted to, I could put the nozzle back on and be a bit more directive around these RAM chips if I wanted to. But we're gonna keep heating. I'm just going to put the comments back up on my phone because they keep going off, which is frustrating. But as you say, we are at the stage of really, what do we have to lose right now? Now, lead-free solder is a complete pain in the bum. It really is. It's just a total joke, to be honest, more than anything. And what we will do is I'll have to run down and get the power supply. But I'll run down and get the power supply and I'll lay the heatsink on because it should fire up. I should be able to fire it up on the bench. I'm going to go now over to the system chip as well. So just to bring that over. And we'll see if we get anywhere with it. The question is, are we getting enough heat in to reball? And that's always the hard part to fully know without specialist gear. You know, when the guys do proper reballing, they actually use a camera to look under the chip as they're doing the reballing to try and make sure that they've got as much heat into it as possible, and they watch for that point that the balls actually change. Evening, what's cooking? An Xbox 360 Wavy Davy right now. We have an Xbox 360, which is my kids' one, which has decided to basically RROD, which is the red ring of death. And what we're doing is we're attempting a reflow on a couple of the main chips. I'm going to go back to the main SoC because I'm not convinced at all we've got enough heat into that to have done it. Now, I'm not sure this, you know, let's go to 490 degrees. So that certainly is a lot hotter than it should be enough to start looking at reballing. It's very hard to tell on any of these chips what is actually at the point we're hitting reflow. You know, it is very difficult to confirm, but we're gonna give it a try. Now we can turn the air down a tad, which will actually give me a bit more heat. Because on this heat gun there is there's a crossover with heat versus air, air versus temperature, and if you have too much air, it sort of drowns down the temperature because it's not a high-end unit. It's good for average everyday use, but it's not the most high-end unit out there. It really isn't. So right, we're going to go for the main SoC again, because that will be the one that is the problem. I can almost guarantee it. And it's a big chip as well, so getting enough heat into this to be able to reball it isn't easy. It could end up being an oven jobby. It really could. Just trying to make sure I get plenty of heat into the chip. Now, as I said earlier, guys, you know, from a leaking point of view this week, obviously we've had the DJI Mavic Mini 2. It's not really leaked, it's just sold. My understanding is the 5th of November. That even might change now. DJI might even bring it forward. Clearly, they've shipped stock to retailers, and Best Buy in the US decided to ship that stock out the door as quickly as they could. I can well imagine DJI are far from happy. Far from happy. Part of the problem with reballing this chip as well is it's got a heat spreader on it, which is going to make life even more difficult than normal. Bit more heat. Now if I just do let me find an area test. So let me just test around on one or two of the VRM units a second. Oh yeah, that's definitely warming up. Yeah, it's definitely warming up. We're going to give it a couple more minutes just so I can just be happy in myself. I've got enough heat into it. Then we're going to go in the RAM. Okay, and then we're just going to go for the NAND chip over here just to make sure the NAND. And this one over here as well. One last go at the CPU. Evening. Evening, hi Taff, how are you doing? I'm just, at the moment, we've got an Xbox 360 in bits on the bench, which is given the equivalent of RROD, which is the Red Ring of Death. And what we're now doing is attempting a reball. Okay, so let's leave that there a second. Certainly a lot of heat there. Oh yes. Oh yes. We certainly have that smell that that board has got very, very hot. So what we're going to do is we're going to cool him off. We're going to give him a couple of moments to cool down. And tried brazing a super tire exhaust once. And what we're going to do is I'm going to go and get the power supply now. I'm going to have to run down the house because I haven't brought that up. I don't need to connect it. I've got a monitor here. I can plug it into this anyway. What we'll then do is we'll lay the heatsink on top. We don't need the full heatsink in place. We can then plug our boards in because everything's on modular on this thing. So this board here goes along here like that. This little Wi-Fi board here, which we want the screw for over here, goes in this weird socket on the side over here. It's like a long USB port, that one. We don't need the CD drive in. We won't need that. We won't need the hard disk in to test it. And just melt. Got temperatures perfect and it just melted. Yeah, it's a bit of a brown art brazing. I haven't done a lot of it. Ow. Still hot, but not too hot. Okay, so what we can then do is pop the heatsink on and it goes there like that. Okay, what I'm going to do is in 2 seconds, I will be back now. I'm just going to get the power supply for this. So give me a second. I'm just going to mute the audio whilst I do it because it might make a horrible sound. So 2 seconds, guys. Okay, so the audio should be back. Hello guys, sorry about that. Just had to get myself a can. Look at the state of the bottom of that. And let's just get the chat back up. Okay, so we've got the power supply in hand. So let me just pop him in. We've got the magic orange light on the back of the PSU. We've got our front board. Nothing else probably needs to be connected. What we do need to do though is we need to plug the fan in just in case, because it might whinge about not having a fan. When you go pip with your chat, when you go picture with your chat and see the inserted video feed, so where one of them is coming over the top, isn't it? Yeah, I need to probably move that around. What I'm probably better doing then is if I stick that over to there and then do that and do that, that probably works better. So good heads up, my friend. Good heads up. Okay, so let's take it back out a tad. Yeah, we're still zoomed in a bit. So we need to get this off the deck simply because it's going to need to have the weight for the heatsink, because that sticks through, and I don't want to stick the brackets on yet. So let's see if we can get this to play ball. That'll do. Ish. No, no, right. You're not playing ball. No, right. Don't you love it when things don't listen? There, we'll do it like that with a bit of tape. Okay, so what we're going to do, I've turned it towards you guys so you can see from your side. We've got the power supply there. So the camera's on autofocus, so it's Sony. Everyone says Sony is fantastic. It's not that great. Now we need to make sure we get this in the right way, because this is keyed, and it's keyed as per the case on the Xbox. And if you get it wrong, it's going to go bang. And I bet you it's the case I haven't got on me. It's the one down the bloody house. That's typical. Yes, okay. So I half stripped this in the house. One more second. That's what happens when you strip half of it in the house, on the desk in the house, and half of it in the workshop. I'm sure this makes great content, you know. We needed the rest of it as well because it's got the button and the LED, so we need that too. We need this bit. So this is on a ribbon cable, so we need to plug this back in. Now obviously when this goes on, it goes on that way, so we've got this ribbon cable that needs to very nicely go back in place. So we're going to just do that too. Good. Okay. And then we've got the back chassis, which has our key for our power connector, so we know which way it's going to go. Because otherwise we will get ourselves into trouble. Okay, so it's keyed that way. It's going in like that. So it's the under panel because that's the connectors on the right side. So we shouldn't see any magic smoke. Just to double check, we might see magic smoke. So let's just hope we don't see magic smoke. No magic smoke. Power supply is still showing orange, looking at the monitor. I couldn't see the LED then. What was it doing? No, look, we still got the flash in. So how many flashes is that? Let's count that up again. 1, 2... Oh, God, that was quicker than I was ready for. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 11, 12. Try that one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Definitely 11. So we've still got 11 flashes. Okay, now what I want to do is just have a look at what this is doing when we're doing that. Power supply is going green, which tells us our PSU should be fine. I think what we'll do is we'll put some voltage, we'll do some voltage checks on this now and see where we're at. And the reality is I've either possibly not put enough temperature into this. I think we'll cook it. I think we might go for that. We'll get the big heat gun out and we'll cook it and we'll see what happens. Or there is an issue somewhere else. But generally on these, it is very much temperature related. So I'm just going to put a bit of weight on the heatsink while I power it up. Now instantly, look, absolutely straight away, as soon as we turn it on, we're flashing. Okay, so now the thing to remember is the key goes down on that one. So we're just going to pop him under the desk. The nice thing is now we can just unbolt the extras. We don't need that a minute. We don't need that a minute. I think what we can then do is get those two out of the way. The only problem with the solder heat gun is it might not be putting enough temp in. Undo the heatsink. It might simply not be putting enough temperature in into the main chip, because this chip is very it has a very big heat spreader on board. So let's get out the big heat gun. Now I just have to find where I've actually stuffed it. Having tidied the workshop recently, it might be somewhere hiding, or it could be somewhere easy to find, but I do have one. And it never normally lives too far away because it's a very handy piece of equipment. It might actually be under these boxes that you guys can't see over here. It's not there. Here it is. Perfect. There we go. The big one. So you guys can see. There we go. Like, untangle the cable. Could do with a bit. You never generally do things like this, do you, when you use them? You always just tend to use the cables tangled up. You don't tend to actually sort these kind of things out before you actually use it to do something. You normally just go, yeah, that'll do. That'll be fine. Let's get under there. And then under there. Cool. Okay. We're just going to plug him in. And what we'll do now is we'll put some proper heat in. If we go to there, and then there. Okay, so we've got, this is a bit louder. Not sure how loud this is going to come across. Yeah, you're certainly going to hear it, that's for sure. Oh yes. Right, so we're going to go high. And we're going to now go for a proper reball. With plenty of heat. And see how it behaves. Now I'm not on maximum here. Now we're going to just go over the whole area. See how it goes. Now they say about a minute on high heat. But it's hard to know when we have hit reflow. You've got to try and make sure you keep the heat moving. You don't want to keep it too static. I can certainly smell the heat in that now. Again, we've got nothing to lose at this point. We'll come back to him in a second. Let's go for the main system chip down here as well. Just again, get in plenty of heat. I can certainly smell it this time. If you guys could smell this. Now, I don't know if you guys know, people do a lot of graphics card fixing. Put their graphics cards in their toasters. And they use their toasters to actually reflow their graphics cards. It's quite impressive. Just now we're just going to heat the other chips on the board now. Just do them. Just get them flowing. And then finally, we're just going to go one more on the system chip, and then we'll let it cool off for a minute or two. And just read Dave's comment. Right, we're going to go with that. There's a lot of heat there now. There's a lot of heat there now. But yeah, the guys, just leaving this cool off a second, the guys who do a lot of graphics card repairs actually reflow them in their toasters. As crazy as that sounds, oh, that's toasty. My infrared thermometer, you can smell it. You can really smell it now as well. Is my infrared thermometer got a battery in it? Like everything, I tend to not have a lot of battery. Look at that, it's flat. It's frustrating. I got anything new with a PP3 in. What's this? That's got a PP3. Let me be interesting to know how hot that actually got. Too hot to trot, maybe. But yeah, so the guys doing the graphics cards, they put them in the toasters. It's fantastic. I just love the fact of people reusing household appliances to repair products. I think it's just fantastic. If you ever want to see a guy who does a lot of graphics card repair, he does a lot. He's known as Buildzoid on Gamers Nexus, and he does a lot around that as well. Want to borrow me? And he's got a YouTube channel. I can't remember what it's called. We're gonna get rid of that. We've nicked a battery from a spare multimeter. Get that one in. Get in. Hey. What's that at now? So that's now currently at about 100 degrees. So that's not silly hot. That's at 84. I don't know if you guys can see. It's just, so what were they? 103. 100 degrees. Still a lot of heat coming off this. A lot of heat coming off this board at the moment. 70 odd degrees down here. We need to let it cool down a little bit more, I think, before we you can certainly smell and feel the heat. We need some active cooling is what we need. Need a hairdryer on cold just to let that chip. Sorry, I got my power cable stopping me moving my chair. Bring that back on the corner. Yeah, we just want to let that wave down a little bit. Cool, put some heat into the desk as well. Wow, never thought about that. Actually, probably softened the desk. Look at that. I've actually softened the surface of my table. Now, this isn't a proper table. This is I've actually softened it with the amount of heat that went into it. That's quite funny. So I keep saying the same thing there. Okay, let's see if I can cool it. Where is my magical desk fan gone? My amazing fume extraction fan. That's disappeared. I was hanging here as well. Everything's not where it should be today. Everything's not where it should be. Okay, so let's get the heatsink on the die, because we know if we do that, that'll start pulling heat away as well. We can start plugging in a couple of our components anyway, whilst we're waiting. So we can plug in our Wi-Fi board on the side, and then we can plug in on the front. We can spin him round, and then we can plug in our external controller board, our wireless board. On the front as well. We can spin him around that way. You guys will be able to see that when we go full screen. And what we need to do is we need to get it off the deck slightly, just so the heatsink will sit on the CPU, because I don't want to clip it back in yet. I just want to let it thing. Okay, should we? It's probably going to still give an overheat error right now, isn't it? Because there's a lot of temperature in there. So let's plug him in and see what happens. Let's go for it. We might get magic smoke, but let's see. Okay, just double checking this power connector is the right way, and it is down. Yes, it is. We've got a finger on the top just so I can hold the thing in place. So let's get my phone back up so I can see the comments. Right, should we see what it does? Solid red. Now that might be overheat. Let's be honest. There's a very real possibility it thinks it's too hot. at this moment in time. And interestingly, the power supply there was red as well. So I think we need to get him to cool down a bit more, because I don't know, mind. I wouldn't say we. I wonder if we've killed it. Let's try it again, shall we? Doesn't like that at all. We've put a lot of heat into it there, but the problem is, so the power supply's on. We've got LED, we've got light on the power supply, and it does go green for a second and then straight back to red. Oh, I tell you what it might be, mind. I haven't got the fan plugged in properly, and it might be clever enough to know that. Should we try it again? Thought I had. No. And it's not even running the fan full pelt. Oh, we might have killed it. More than it was killed before. But what we might need to do is let it go. Should we have a look at what's solid red light on Xbox? Just to check in. Good old solder. Yeah, this lead-free stuff is terrible. What are they saying solid is? I'm just... went solid on my... I'm just interested to see what they... is lit with a single red dot. I'm just interested to know what the solid is. It might actually have a... Just reading through. No, nothing there. Nothing specific to solid. It could still be temperature related. It really could. As I said, there's a lot of heat gone into that. Oh, what are they saying there? Just to say solid red. Okay, that's nothing particularly helpful. Lead-free solder is a complete pain in the ass. There's no in between on this. Right, what are we like on temperature now? Let's just... we're certainly getting cold now. Okay, it's lukewarm at best. From a feeling point of view, you know, there's nothing, you know, I'm not expecting the heat there to have really, that amount of temperature to really give me a problem. Okay, let's see if it does anything different now. Keep an eye on that red light there. Now that is instant solid red. Oh dear. Oh dear, oh dear, oh dear. We might go for a full-on reflow then if that is the case, because I'll... nothing to lose. Nothing to lose. You know. Just hold it. No, we're going to go for it. We'll put a ton of heat in one last time. Otherwise, she will be for the scrap, unfortunately. Or I might oven it. I may, if I don't recover it on this, I may give it the oven treatment. Now, what I want to do a minute is I just want to put something metal under it so I don't melt my desk any more than I already have. Okay, so let's take that out as well. We don't want that. Okay, so we're going to have a bit more noise, guys. We're going to put a bit more heat into the bottom. There's a red light of the PSU. Blowtorch. Yes, let's get the blowtorch on it. we're going full. So this is the CPU side. Just over by here, so we're just going to preheat. On this side of the board. Of course, loud as well, isn't she? I'm just touching some solder points there with nothing on them, just to see if it's melting. Because, you know, if those solder points melt... Oh, yes. Okay. Okay, so we've done that. So we're very carefully going to flip over. And let's go for it. Full heat, full steam ahead. Full steam ahead. The phone keeps turning off, so I can't see the chat. Very frustrating. I'm going to keep an eye on by here, look, because they're solder pads. So if they start melting, I know I've got heat into that area there, you know. Oh yeah, they're hot. Oh, we're hot. We've moved that. Did you see that? I don't know if you caught that. We reflowed that cap. We reflowed that cap. That is loose. I just tapped it. Yeah, that. Okay, so that is now reflowed. 100%, that chip has now reflowed. I don't know how much you guys could see of that, but I could actually move that chip a tad then. An absolute tad. Now what I did was I knocked it left and knocked it right. Absolute minuscule amount. Tiny, tiny, tiny amount. Now the only thing we've got to be a bit careful of, we've got to let the temperature go down now, and just make sure nothing's falling off the back end of the board. We put a lot of heat in that time. We put a lot of heat. Now that isn't to say the issue isn't with some of the RAM chips here as well. You know, I just want to check. Yeah, you're back down. You're back down. You can see he's actually moved. They're out of line now. If you have a look, they're actually staggered. Yeah, he is back. Caps have gone off. Yep. We can get the rest of this heatsink compound off. So that has reflowed. That has 100% reflowed that time. The question will now be if it is the main SoC. If that doesn't work, we'll reflow him because I put a lot of heat into him as well earlier, which is the other SoC. I'm not going to mess with it now. We're going to get the heatsink back on that as well to pull that heat away, because it will help pull that heat away from the chippers too. Let's just take him off there a minute. Obviously we can't power it up on that, we'll short it out. It's actually quite interesting, that, Mark. It's funny because if you take a computer CPU, Mark's question is, for those who haven't seen it, how much heat can they take when they're not on? every chip will have a rating of what the maximum heat for a maximum amount of temperature, whether it be chip, capacitor, resistor, and you use that as part of your soldering when you're manufacturing something. You know, if you take a normal processor in a computer, when running, anything over 90 degrees is dodgy ground, or over 100 at least. Whereas 200-300 degrees for a very short period of time isn't an issue. It really isn't an issue. Now, obviously, for this silicon, I can't tell you. I can't go on the spec sheet and look. But on any chip on a board, you can actually go on the manufacturers, and as part of their design, they'll show you in the spec table what the maximum permissible temperature is for a short period of time. Now, while we just let that cool, we'll if I hop onto the desktop, we can have a look. Like, I've got an FET here, okay, which is, it's a piece of silicon. It's one I've blown up. If it's an FET transistor, I've blown up off a power supply. I'm just trying to see what the actual number is. Let me just bring it up on my headset, just so I can see. P5NK80Z. P5 8K N0Z. So P5 8K. P5, was it P58? P5NK 80Z. So this is an FET. PNK. This is an FET switching transistor. Data sheet. It's an ST Electronics, microelectronics device. Let's bring up the data sheet. And on this component, on this data sheet, what we will have is that maximum junction temperature in use and maximum junction temperature in soldering. So package mechanical data and packaging mechanical data, and it should be these. So what we want is, if we go down onto the device, what we should have, now whether they're going to put it on a transistor or not, I don't know, but most ICs let's have a look. So that's the mechanical data there. Let's just have a look if there's anything in here that's temperature related. The problem is you're dealing with, okay, let's look at something like an SoC, STM32F427. Okay. So this is a standard CPU, pretty much used in every flight controller, in fact. Yes, except the cookies. Go away. Thank you. Documentation, data sheet, just to make sure there isn't something else. There we go. So we'll go for the main data sheet, and then on this what we should have is, let's just have a look, external controllers, yeah, no, we don't want that. Temperature sensor, no. Pinouts and description, electrical characteristics, no. Operating conditions, they usually label it, I can't remember what they label it as. Packaging, thermal characteristics, so 225. Okay, so this is like the thermal, maybe this is the maximum as part of that in use. So that's the power dissipation temperature that it should not go over. But then there is a separate temperature range which is used as part of manufacturing, and they label it in here somewhere, but it's always a bit of a gamble to find it. And it's usually for each SoC. So if we look at STM32 soldering temperature, the package body exposed to radio temperatures because the package is the whole package is good. Refill process. So recommended. So here we go. MCUs, they've actually got a document, soldered recommended packaging information, lead-free. So here we go. They've actually got their own document specifically for those processors. So if we go down and pin count package, so different packages, pin count, okay, and then we've got handling, soldering, single-sided reflowing, pack and intended the flowing type, and then they're showing you the flowing profile, because when they do these things, they actually solder them on a profile where it gets thermal shock. So you build the temperature up, you preheat it, you dry it, you reflow it, and then cooling, and then you've got them down here. Look, so they recommend a preheat temperature of 150 degrees up to a maximum of 200 degrees, a temperature of 217 degrees in the maintained temperature for 60 to 150 seconds, and then you've then got the cool down temperature, and that's the recommended. So, you know, look, you've got what, 200 degrees there as part of the normal soldering temperature. I got my headset on, look, my magnification. So 300 degrees, you know, we probably went well over that just now, to say the least. Our heatsink is working. Oh, that's nice and cool. I'm happy to plug that in now. Let's go for it. So you have got to be careful, though. You can damage silicon, and then there is a possibility I overcooked this. There really is. I'm not going to pretend that isn't the case. Okay, so we've got red light on there. Dead fly. We're going to go, oh, straight red again. Now, the only thing I am going to do is I'm going to reflow this, because I reflowed it. I messed with him earlier, so I just want to make sure that's reflowed as well. You know, we've gone straight to the red light again, so it's not looking good. It's not looking good in any shape or form. Some of these you can win, some of these you can't. Some of them you end up just doing too much damage along the way. Yeah, that's not looking good there. Okay, so let's just have just a closer look again, just to make sure nothing else dodgy has happened. So yeah, all looks fine. All the capacitors around it are good. We've definitely reflowed that chip, that's for sure. Just want to make sure these caps are all in nicely, because we melted a couple of these. As I said, the legs moved on these. We'd put that much heat in, we'd actually reflowed them. Looking on the bottom of the board, that's all fine. We've done no damage there. So I'm definitely going to go with a quick one more reflow on the other part. Yeah, when they're doing proper soldering, it's all about a curve. So you program it into the module, and it builds it up, and it heats it for, you know, and the melt time is very short. So what you do is, in proper manufacturing, if you think about it, there's a point of the solder is melting. So, for instance, this is lead free, and what they say is this. Actually, that hasn't. The label's missing off that one. Has this one got its temperature on? No, these are all quite cheap. Good solder will have its temperature melting point. So, lead free is different to leaded. Leaded is easier to deal with. And what they do then is you bring the temperature up to right to the point before it will melt. And then sort of, 150, as they were saying, 180 degrees. And then you tip it over the edge for a very short period of time to melt it enough for the balling to take place, the chip to solder, and then you bring it back down. But you can't bring it back down too quick, because if you bring it back down too quick, it will crack, it'll move, it'll give other problems. But you can get soldering tables. I don't have one. You can get tables for doing them. Right, we're going to go for a bit more noise again, guys. We're just going to thing this one here, because that's the one I messed with earlier. And I haven't reheated him since, so I just want to... I'll just get my screwdriver out from under this damn case. There we go. And what I'm very gently doing is just tapping the IC to see if it moves. And there's some solder pads down the side which I was checking as well. Oh, he's loose. He's loose. Now the problem is you've got to be so careful because even touching it will kill it. You know, these holes are that small. If none of this works, I'll take it off. I'll take both chips off. We'll have a look. We'll never reball it at that point. Let's just do the memory as well. Just giving them a... No, I am not going to touch the memory. Even touching that might have been too much. Okay, we'll call it that on them. We're not going to put too much into that. So we're going to see what this does. If this doesn't work, right, for you guys, we'll take them off. We'll take off the SoC, and because I'm at a loss at that point anyway, I'm not going to send it for repair. I'm not gonna do it. You know, it is quite the science, the whole soldering process on these things. But I also, if you were watching earlier, you'd hear me mention that about guys who reball and repair their graphics cards in their toaster. I just love people doing that. You know, I just love the fact of that homegrown repair. Same as this, but this is always a risk. Unless you do this daily, this is always a risk. Now, a very smaller risk would have been me ovening it, which is you put it in the oven for, say, 200 degrees for X period of time. That would have been a smaller risk, because that way I could then have controlled what happened. Everything would have sort of flowed and then reflowed. It's possible I've put too much heat into the chip. That is a possibility. You know, I was at the stage of not a lot to lose here, so I wasn't really gunning for an out-and-out fix. But I could, you know, I could choose not to take the chips off and bung it in the oven and see what happens there if I wanted to, but I'm not going to lose too much sleep. I'll probably end up having to buy the new Xbox. That's what will end up happening. Not that it's available yet, but it's, you know, it's worth a shot. Like if I was being really keen, I'd actually straighten that up again now, because they're hot, to say the least. These are all still very hot. Let's get that heatsink back on, I think, is what we'll do, because that helps drag that heat away from that chip and that area. Oh, she's warm. Oh, yes. Unfortunately, you can't win them all with these things. But it is frustrating that technology like this fails. It shouldn't fail. It really shouldn't. There's no reason for this to... Ow. That's very hot. Let me get it at a balance point. There you go. We're not going to plug it in yet because it's still very, very hot. Yeah, we can certainly get some stuff off it. You know, the problem with these is reballing them can be done, but you know it becomes a stencil job. You need a proper BGA stencil to do it. But we've reflowed him. And I don't know, did you guys see it move? I don't know if you could actually see that, what I was doing. Be interesting to know if you could see it just tap to the side slightly. If you couldn't, we will do it now. And we will do it properly so you can see the point that it is loose. And we'll flip them off. And we can salvage some stuff off this. We can get all the transistors. We can get some of the transistors off, the FETs. We can actually do some surface mount soldering. You know, it's how I've got a proper video on it. Let's go for it a second. It's still a tad warm, but let's not wait too long. It's still bloody hot there. Okay, yeah, no, that's not looking good, is it? In any shape or form. No magic solder, though. No magic smoke. See, the only thing you've got to be careful of is the temperature, and the temperature has fully dropped. Because there are thermistors in these as well, and if there's still a ton of heat around the thermistor, interestingly, there's clearly power, because I can... Okay, so we're just going to let that cool a tad more a second. I'm not going to overcool it. I just want to let it... I just want to give it a proper chance to cool down. I'll pull a board up while we're doing it. I'm just triple checking I'm not going bloody mad, and I have got the power supply in the right way. Yeah, yeah, we have. Just to make sure. Let's just pop him up to the side a minute and let that fully cool off. But, you know, we can look at something like a board which we've got here. You know, let's get some focus on this. I'm lucky I get given some boards every now and again from people to take apart and stuff. This is just one that's being checked for a different project. And, you know, we've got all sorts on here actually. You've got your chips on here. Wait a minute. I need the nozzle on that. Let me just put the nozzle back on the heat gun. I took it off. Right, that's better. Okay, so I get myself a set of tweezers. Pair of them, pair of them. Okay, so what we're going to do is let this heat up, starters, and let me get some of the magic stuff. Now, while we're waiting for the other one to dry, whenever you want to remove anything, there is one magic key, and that is flux, okay? Flux is like the #1 important tool. Now, this board is clear coated. Sorry, I'm just trying to find where my tube of flux has actually disappeared to. It's not sitting where it should be. We'll need that. Where's it gone? Where's it gone? Another pair of tweezers. Yeah, there was a quick flash, wasn't there? Where's it gone? How dare it disappear? Oh, so it's there. Blind as a bat. Actually, let's get that off a minute. Have I got a better board here? Let me just find something. That one's been pretty mangled in the past. Probably not. Yeah, one of these. 2 seconds. Yeah, one of these. Okay, so if we look at this. Okay, so we've got I was given this one. So we've got a chip down here, right? Okay. So what we're going to do is we're going to remove this IC as if we were going to replace it. So the first thing we're going to do is put, as Lewis Rossman always says, a generous amount of flux. Okay. I'm going to just put it where my hands are able to. Oh, I need more length. Oh, I've unplugged the solder station. Come on, you. Give me a bit more. I'm not on the normal bench, so yeah, try that again. So we're going to do this one while we're waiting for that board to cool off one more time. We're going to do this one here. So what we're going to do is heat him up and let the flux flow. Let me get it on the right angle for me to be able to get the tweezers on him. And we're going to let this one flow. So if we were, you can see the smoke kicking in. That's the flux burning off. Now I haven't got my solder station. Now I've got this pretty hot at the moment. Come on. Come on. There he goes. So we've removed him. We now have that IC off, which is there. Okay, so if we now wanted to tidy this up, what am I on? Rework, solder, strip this. I'll go for that, yeah. So I'm just setting the temperature on the soldering iron. So we've removed the chip there. You can see he's now off. What we will do now is we'll just clean him up slightly. We're letting the iron warm up. Now what we're going to be doing in this, because this board will be using lead-free solder as well. Everything is using lead-free solder now, pretty much. Anything that comes off the shelf. So we're just letting the soldering iron get up to temperature. And what we'll then do is we will clean off the pads. We will clean them off and get them nice and tidy. And then we will resolder the pads. Make sure that they're fresh solder and then reapply the device. So again, the next thing whilst we're waiting is flux. You always need flux. Flux is the #1 key. Why do you not attack it from the underside? Because the board, the heat just won't get through the board. The heat just won't. You just won't get the heat through it. Where are we at with the iron? We're 200 degrees. Okay. Ooh, what tip have I got on that? Forgot. I was doing some big work, wasn't I? Okay, look at the size of the tip on this right now. It'll be fine. So what I'm going to do now is I'm just going to turn it. Now the first thing I'm going to do is just put some heat on the pads. Just run some solder over the pads. I really need an extraction fan for this part here. Now what I'm actually doing at this point is just mixing that old solder that was already on them with new solder. We're then going to nicely heat the pads up and clean them off with the solder braid. And what the solder braid will do is completely clean the pads of any existing solder. So it will remove all of that lead-free solder. So now you can see that the pads are completely flat. There's no solder on them at all, which is no good at this point because we do want a little bit of solder on there, to be honest, to be able to stick the IC back on. So what we've now done is, because remember this board is made with lead-free solder, but we're going to put the component back on with leaded solder because it's far easier for all repairs. You don't want to mess around with lead-free. It's not fun at all. I've got some here, but it's crap. So what we've now done is the flux stops the solder running all over the place. So what we're then going to do now is put some fresh solder on these pads. Now this nib is huge. I would not normally be using this nib. We're going to just put a nice coating of fresh solder on those pads. Like that there now. You can't see the light isn't great, but we've then got a slight coating. Now that will be enough to hold it in place. It won't be enough to fully, you wouldn't leave it like that. We'll touch it up after. So what we're now going to do is take our IC we're then, cable's a bit short, but we're then going to place him back in place and just get him tacked down enough that it stays where I want it to stay. Because remember, I've put a little bit of solder on these pads, not too much, just enough. Okay, that's enough. Tack it down, and we're just going to hold it there, not move. Now that is enough for the IC to actually stay there. It's not going to move, but the pins are not properly soldered at this point. We cannot class that as well soldered. And what we will do now again is add a bit more flux, because remember the flux keeps the solder where you want it to go. And what I should have is a much smaller nib on this soldering iron. A much smaller nib, but this will actually help prove a point. And that is the flux will stop the solder going where it shouldn't go. The solder will only flow where I want it to go. Now what I'm going to do then is run the iron tip down the pins one at a time to make sure that there's plenty of solder on each leg. We've done that side. Let's flip him around. And this is a bit more difficult because I've got some smaller components this side. But again, I'm just running the solder down with the iron. There we go. Now what we need to do is really clean that so you can see it. So what we would then do is get my little bottle of IPA. Now, I have a tiny little spray bottle I use, but it evaporates away. So I normally end up having to top it up before I can actually use it. But again, my bench is such a mess. There it is. Look, my little bottle of IPA, but it's empty. So let me just fill it up, because you know what IPA is like. It evaporates away at the first opportunity. Unfortunately, I haven't got a funnel, so when I put it in, it goes everywhere. I think I put probably 1% in the bottle and 80% on the floor. So we've a little bottle of IPA. We'll then spin him back around, because obviously you've got all that flux here. So what we're going to do is give that a good spray a second. Again, IPA will do no harm to the electronics. I'm just going to take a brush. Just to brush away some of the flux. And then what we'll do then is have a look. And I have got a bridged pin there. If I have a look closer, we've actually, there's a pin bridged, look. So we'll just take the iron to that. There we go. That's him resolved. And that's him back on. That's it. That's him done. It's that simple. It really is. Yeah, that's a good point, Steve. Yeah, I'm just letting the Xbox cool. I'm going to try it one more time, and if not, we're gonna burn it. But yeah, and you know, we've taken a chip off, we've put a chip back on. This lighting is not really good enough. But you know, even you know, and if we want to then go down to some of this low level stuff, you know, this very small resistors and stuff, I have something called like this. This is very good. I don't have a microscope, but I have this little headset, which makes me look slightly mad, but it's a magnifying headset, and it's really good. It's got a little light on for doing close-up magnification stuff. So again, if I wanted to do something like one of these down here, so if we look down here, we've got some resistors, capacitors. So if I go down here, and put a bit of heat on. There we go. Lift him off. Now that is absolutely tiny, so we don't want to lose that one. But again, the process would be the same. Again, I'm using a ridiculously big nib on this. We're going to, again, remember, number one rule. Flux, flux, flux. This nib is huge. I'm not changing it now because it's already on there. But we're going to flux, flux, flux. Clean the pads. Put some fresh solder on. And then we're going to take this cap. We'll use the heat gun to actually put it back on because it's such a small component. It's actually stuck on the sides of the tweezers. It's that small. Ooh, he's blown away. Let him sit in place. Now he isn't fully finished. What I would then do is get him in, and then I would normally use something like this, okay? This is the soldering tip. You won't be able to, it's a needle tip. If you look at it, it's absolutely perfect for doing this kind of small component. But if you've done enough of it, you can get away with the chisel. You know, if you look at the size difference on these two tips, you know, if I look at that to that, if you just look, it's ridiculous. This is my wiring tip. I had this because I was doing an XT60. That's why this tip was on. But again, we could still tie the solder, touch either end of the component very carefully. Yep, done. Again, clean him up, bit of IPA, get my headset off. Here's my brush to whack it off. Get me brush to whack it off. There's a bit of crap around there at the moment as well, which didn't help. But let me wipe it off. Yeah, there's a bit of burnt gunk on the board, but it is back on. It's soldered in place. You can't see it very well. The bench over there is slightly better for doing this stuff. So, yeah, you know, it's fairly straightforward once you've done enough of it. Right, let's have a look at this damn Xbox. Let's see if we think it's working. Shall we? Okay, let's bring that back up. Get the chat back up. They are. The only problem with them, Steve, and I don't know if you've noticed this, you've got to get in way too close. I want a microscope. I really do want a microscope. The only problem is you've literally, you know, the focus point on it, just to show you, is, you know, when I'm at the board, it's there. And when you're trying to work that close, it's too much. I need a different set. Okay, that board is definitely cooled off now. That board is cold. Let's do that. The power supply light is amber. It's down there. I'm just going to put something under it again, just so that... oh, that's got metal on it. We don't want that. Roll of insulation tape. Just so that heatsink is down. Let's have a look. It's interesting. Getting no light at all, look. We definitely in properly. Let me put that back in properly, just in case that's fallen out. Right, let's just do this again. Pull that forward, pop that down and in. Lock him in. Good. Good. Okay, let's just do that again. Not even getting fan spin now, are we? Okay. Or turn on. Power supply is amber. Let's just check this again. Oh no, I've done that the wrong way, look. Idiot. Let's just swap that around. Because that goes that way, so yeah. Silly boy that I am. Okay, try that again, shall we? Yeah, we're not getting any life now, are we? We're getting the beep, but no LED. I hear a funny sound, but I can't figure out what it is. It sounds like fan spin, but it isn't fan spin. Yeah, no, not good. So obviously the last thing we did was the system on a chip. Cable the wrong way, power cable. Oh, that one was the wrong way. No, that one's always been there. Deadpool has always been up there. He's day one. Power supply is definitely in the right way. Definitely down. Just making sure I'm not going mad. Yeah, definitely down. Yeah, that's the bottom of the board. That can only go that way. That can only go that way. So that has to go that way. No, it looks like it's dead, Jim. It looks like it's a killer. Now, I'm trying to decide whether to oven it and see if it recovers. Because, look, you never know. Because one of the benefits to the oven is, if you oven it, everything will sort of redo that. We know I moved that slightly just then. And whether I've... Yeah, she's not straight now looking at it. She doesn't look perfectly straight. I touched it a tad, mind, and I mean that's all it takes, isn't it? You know, it only takes a minute, girl. It only takes. So I don't know. I haven't decided whether to oven it, put a ton of flux on it and oven it, and see what it does before I out and out destroy it. We could, though. We could. It's getting late. This is the problem. It's getting very late. What time is it here in the UK? It's nearly 12 o'clock. Right, I'm going to do one more thing before midnight. One more last hurrah before midnight. Let's do it quickly. Because we know we had movement until we moved that around. Okay, so what we're going to do is just redo that a sec. And see if it... And the reason I put flux on it is to allow the flux to get underneath it. Because the flux will actually go under it. This flux is getting a bit old as well. Oh, we're smoking now. Oh, yes. I don't know if you guys can see the smoke. Now, the flux will actually help it reball. He's now loose. Did you see that move then? I don't know if you guys did see it move. It definitely moved. Oh, we're smoking. And the idea of that was to allow it to resettle itself. And we're going to do the same on this. A last hurrah on the main chip as well. And the good thing with the flux is, when it's not smoking, oh! We put too much heat into a couple of the capacitors. Should we wait for one more to go? Any more? No? That's what happens when you put too much heat into the board. We popped 2. That's quite funny. But it was the last hurrah. It was the last hurrah. So what we've done is we've blown a couple of the caps. He'll be good. They'll be gone anyway now. They'll be gone. Yeah, they're certainly gone. We had 2 let go. Two have blown nicely. We reflowed that very well. That reflowed really, really well, that one. That didn't go well. We'll plug it in though to see what it does. We gotta do that. We gotta do that. Oh yes, we well and truly killed it. Too much heat. Too much heat. But never say never. We will plug it back in. We'll let it... we definitely reflowed that. We definitely reflowed that. That is for sure. But that's not to say it's dead. It's only a couple of caps. I can replace the caps. You know, if we can get him to come back, we can replace the capacitors. That is not a problem. Capacitors are not an issue. And it will run without them. Ow. Ow. It will run without them. It'll be fine. It won't run properly, but we could survive without them. Just looking. We're going to have to let it cool off, that's for sure. Did they take their legs out as well? That's quite funny. So I clearly melted the solder because if you look, not only have they gone bang, right? Where are they? They're here. Here's the line. But they've desoldered themselves as well. They've desoldered themselves as part of the process. We definitely got hot enough. We definitely got hot enough. I am now happy that is reflowed. That I'm not so sure, but that is reflowed. That is sound. We're also missing a capacitor. That's fallen off somewhere. It will happen. It will happen in the process. Right, should we have one last hurrah? We're going to have to put the heatsink on it before midnight. And then if this don't work, I'm calling it a night. They're going to be up early tomorrow. And then I'll do another live stream where we will salvage what's left of the Xbox. We'll do a video on ripping it apart. But we killed it. We killed it. We're going to plug that in there. What output is this power supply, by the way? I haven't actually looked. What is it? It's 12 volt. 12 volt and 5 volt. Where? 12 volt. How is it 12 and 5? Oh, yeah, because it's dual, isn't it? Yes, 12 and 5. So it's 12 volt and 5 volt. I would admit to totally killing an Xbox this way in the past myself. And then sell the bits on eBay. Yeah, no, I wouldn't sell it on to anyone. Unfortunately, I do know there are people who have done a lot of this reflowing, and they get experts at it. You know, you've got to break things to learn, and the learning of that situation was no. How much heat's left in this now? Yeah, let's go for it. No magic smoke. Not got the fan plugged in. Let me just plug the fan in. I've already had the magic smoke. I would laugh, though, if it did fire up. I think we'd all laugh. No, I can't even get ping now. What's the power supply doing? Oh, no, the power. Sorry, the thing put at the back of the supply. Look! Look! We're back to red light. So we reflowed him. We reflowed the SoC. 100%. We reflowed him. And that's now correct. That's now worked. That's back correct again. That was wrong, and it's now correct because we're back to the situation we were in. But we're back then to the solid light, which is either the main SoC isn't reflowed correctly or another issue. Now, those capacitors wouldn't, in my opinion, stop it firing up. She should fire with them gone. It would be unstable, but it would power up. It would power up with them gone. See, oh, and fan spin. You know what? I'm tempted to do one last reheat on and reflow that master chip. Because I'm not convinced it's over. I don't want to let go now because we've made a little bit of progress. It's amazing how much punishment electronics will take as well. At times, it is surprising. I'm tempted to oven it just to see if it does. I'm tempted to either put more heat into the SoC and just check it to see if we've definitely got it. There is still hope, Steve. Steve, there is still hope. There is still hope because that I definitely knocked off earlier, but we've got that now back to where it should be because we're back to this stage. Now, I think my personal belief is, I think the main SoC when I did that earlier wasn't right because when I reflowed that sort of wiggled back. If you've ever done it, see the surface tension of the solder will pull the chip correct. That will sort itself out. Now, one of two things has happened. I've either killed the main SoC by putting too much heat into it, which is a real possibility, or I've knocked it off level and straight. Should we go one more? Should we? Just want to make sure it's not heat still. The other thing you've got to be careful of is on these, they have thermistors under the, as I mentioned earlier, they have thermistors under the SoC, and it can be still substantially hotter under there than it could be anywhere else. Or I could burn the thermistor out She's trying. She really is trying to fire up. I don't like giving up on things. Not until I've really broke them. And when you really break things and you're still making progress, what to do, what to do, what to do. Just having a look. Everything looks fine in there. We've lost a capacitor from somewhere. That won't make a difference. It'll be fine without that. It'll be fine. We lose capacitors on things all the time. I'm really tempted to give that one more shot. Less heat this time. Trying to get my phone to unlock. We're going to be here at 4 a.m, aren't we? I'm going to go one more. Let's go one more. We're not going to be 4 o'clock, Mark. One more. I've got to go to bed because I've got to get out at 7 in the morning. But we're going to go less heat. Flux, less heat. Flux has gone on. Try not to blow up any more capacitors. I've got my flux in my hand as well. Let me just put myself up so you guys can see. I've got my flux in my hand as well. Got tweezers. Trying to be a bit more direct with the heat this time. We're boiling the flux around it. It's still not reflowed yet. I'm just going to keep my head back just in case one of those caps does let go. Oh, yes. Yeah, I don't know if you guys saw that. Okay, that's reflowed. I don't know if you saw that, but I knocked it and it jumped back. Definitely reflowed. Definitely reflowed. And again, the surface tension will hold it where it is. So this is the last hurrah for that now. Definitely the last hurrah. Give it one last go. We don't need sleep. Yeah, this is the last hurrah. It definitely knocked straight. That's as good as it's going to get now. There's no in between. That cap there is going to blow. If I'm not careful, he's bulging. But I can replace these. These are very simple caps. These aren't a problem. These can be replaced very, very easily. So it's just really, I'm not worried about blowing stuff like that up. What we've got to be careful of in this is knocking the memory ICs. Now we have heated these, and there is a possibility I've screwed them up as well. I'm not going to do them tonight. If it's exactly the same on red, what I'm going to do is leave it tonight, and tomorrow I'll reflow these 4 and see if that does it. And if that doesn't, it's end game at that point, because I'm now happy I've reflowed that chip there 100%, the one you can't, the main SoC. I'm now happy I've reflowed the Xbox chip 100%, more than happy with that. And it will just be these. If that isn't the case, then it's end game, and we'll call it a day with it. We'll see what it does. I'm just going to let it cool off a little bit. I'm going to get it off now. I'm just waiting for it. I don't want to move it until that heat really does soak out of it. And then, there we go. We're going to get it down. I didn't go live on Sunday, guys, because I had some stuff I was doing. unfortunately, I couldn't make it. Got some cool stuff coming up, though, on the channel. Today, I've had a delivery from High-Tech in the US. They're CAN-based servos for Ardra Pilot. They've arrived, or for Ardra Pilot and PX4, but the CAN bus servos, very cool. Going to be talking about them. I got 1 or 2 videos coming up on drone hacks, actually, and I'm going to be talking a little bit about firmware modding for a couple of the DJI aircraft, because there's some interesting things I want to talk about on that. I'm not going to talk about removal of legal height limits. I'm not interested in promoting that, but there is some interesting capabilities within this software that allows you to do some quite cool stuff, and there's no reason DJI can't offer it. Now, while I'm just waiting for this cool, I'm going to remove this cap here. He's bulging. I'm not happy with him being on the board. He could cause problems in itself. These could cause problems being hot, but I'm going to remove him. I'm just heating the soldering iron quickly. So while I'm waiting for it to cool off, I'm just going to pop him off as well, because he's bulging, and bulging caps are never good. They're never good. But we're going to be talking about that. Now to get that underneath again, and then the heatsink back on the chip. Did you see the chip move? Obviously, I was looking at it. Could you guys see? Let me know in the comments. Did you see it wobble? Did you see, you know, that slight wobble I had on it? I'd be intrigued to know if that actually come across on camera. Actually, take that off, because I need to remove that cap. I'm going to just remove him. I wish my phone would stop locking the screen. Come on. Soldering iron's heating. We're just going to get that cap off. I'm not happy with him at all. Just soldering the solder on the ones that blew up. That must be a great bit of footage. I can't wait to look back at that. The bang. I hope it went well. I'm just going to desolder that one cap. Ah, it'll be on the playback. It'll be on the playback. I'm just heating. Getting heat into bloody lead-free solder is such a pain in the ass. Okay. Ow, it's hot. Just going to take this cap off before we... because you just don't want anything there that you know might be an issue. So we've killed him. We're just going to take him off just to make sure we're okay. He's just, it's because of the heat. You know, it's simple as that. It's because of the heat. Good. Cooling off nicely. Okay, guys, we will go for one last takeoff. One last takeoff. Get the chipset on board. Plug in. Get a power supply. We have good light on the power supply. Just going to put my hand on there just to put some weight on the cooler. Ah, boring. Well, we haven't made anything worse. So that's interesting. Because I'm now satisfied that's reballed. Yeah. Interesting. Okay, well I think that's obviously we've hit a brick wall tonight. Okay, so that's the reality of that one. Now I'm not going to end this there. I'm going to dig a bit deeper in this one and see what I can find out. Because I don't think it's over. It's not over until the fat lady sings. And, it's not over until the capacitors blow up, and they've certainly blown up. I haven't got anything that small here. I'm not convinced they're going to stop it firing up. Their caps is part of the power rail, and whilst they will help with noise suppression and things like that, there's plenty there. There's still 3 or 4. It should fire up without them. They're a passive component. Again, it would affect stability, but I wouldn't be expecting them at that point to have an effect on the unit firing up. I could be wrong. So then it begs the question, getting the heatsink off, is it worth me ordering in a couple of cheap caps? Because they're only going to be like 10 pence each. They are 2.5 volts. So they're on the low voltage rail. They're very much on the low voltage rail. But they're all linked. They're all in the same batch. So we still have 3 there. So I'm not concerned about them at all. I'm not concerned about the SoC. The only thing we might have done is killed the SoC. But I'm not convinced. I'm not convinced. The only other thing is we have heated the other RAM up. But no, I think from a Tonight point of view, guys, I have exhausted the options. I'm pleased that we were able to reball that. You know, I'm convinced we've reballed that correctly. I'm happy that's okay now. I'll be honest. I think we've got that okay. The problem is, though, have we damaged it? Has one of the memory RAM chips moved? Is there something else at play? I'm just looking around on the board right now. You know, all the other caps look fine. I'm not particularly concerned about them. Yeah, I think interesting is that end one's on a separate rail. Okay, so that's a separate part of the VRM. But no, I'm not particularly concerned we've super killed anything. But I think what I'll do is I'm going to have a poke around tomorrow, and I might go live tomorrow night. And if we can't fix it, we will take it apart and we'll get these 2 off and have a look at what's going on there. I just am wondering, is there a thermistor under the SoC? And if I've killed that, it'll just permanently give me problems, but we'll see. Anyway, guys, let me just check the chat before I go. It defo moved. Yeah, chuck it in the oven while the wife's out. I am really tempted just to see if anything, you know, things. Thank you for spending a bit of time with me. It was just a quick live stream. I'm going to try and do more random ones like this as I'm just doing random crap. You're never going to fix all of these things. Unfortunately, with problems like this, they're renowned to have problems. Even when people have reballed them, it might not have been a balling issue with this. I still don't know. It could have been an actual component failure. If I could get it back to flashing, I'd then be happy that it's a component failure, but we'll see. Anyway, guys, stay safe where you are. I'll probably do one tomorrow night. We'll do part 2 tomorrow night of the Xbox challenge, and we'll see if we can get it going, and if we can't, what I might do is pop it in the oven for 40 minutes tomorrow, and then we'll fire it up on air and see what happens. Anyway, stay safe. I'm going to go over to you and kill the stream, and I will speak to you guys again soon when I find the button. And we're going to end in 3. Oh no, I still haven't found it. Where is it? It's over here somewhere. Right, stay safe, guys. Take it easy. I'm going to end in 3, 2, 1. End stream. End stream.